The next case for permutations. What happens if some of them are the same? So we've got n objects. I'm going to arrange them all, but they're not all different. So some of them are the same. All right, to come up with a pattern, let's start with a really simple case of I've just got two objects. Now, if they're different, obviously, two ways of doing it, or as we prefer to think of it, 2 factorial. We could have AB or BA. But what would happen if two of them were the same? Well, now there's only one. So the question is, how do I get from 2 to 1? Okay, we could divide. We could subtract. There's all sorts of different ways we could get there. So let's investigate further to see if we can't pick up a pattern. Let's go with 3 objects. If they're all different, so now obviously we've got a few more cases. 3 factorial, 6. If we make 2 of them the same. Now back here when it was 2 cases, you said divide. Divide by what? 2. So are you suggesting we divide by 2 here as well? If 2 are the same. So we should end up with 3. Yeah, I think you're right. It is divided by 2, but more importantly, it's actually 2 factorial we're divided by. And as you can see, we do end up with 3. So if all 3 are the same, we're not going to divide by 3, but divide by 3 factorial. We should end up with just one case, which obviously we do 1, 1, 1. So it does appear to be that what we divide by is however many are the same, that factorial. Let's check it out with 4 objects and confirm that that does work. Now obviously 4, we've got a lot more cases now. There they are, 24 of them. We'll make 2 of them the same. Okay, yes, it did halve, or divide by 2 factorial. 3 of them the same. We're down to 4. 24, we have divided by 6. 3 factorial, that did work. So if we made 4 of the same, again, we divided by 4 factorial. So this does appear to be the pattern. So if we've got arranging n objects, but x of them are the same. So it'll be n factorial divided by x factorial. Because what we are doing is similar to when we didn't use all the objects. What I'm doing is I'm dividing by the number of ways I could have arranged those objects if they were different. But because they're the same, well, we no longer have all those possibilities. So I divide by that many possibilities. So number of ways of arranging the n objects, number of ways of arranging the like objects if they were different. Okay. Connaughton. It's a surname of a student I taught many years ago, but I liked it because they got lots of repeated stuff in there. It's not a bad word. So how many different words can be formed using all the letters of Connaughton? So all up, there are 11 letters in there, but we do have 3 n's. So that's the 3 factorial, but we also have 2 o's. So that's the 2 factorial. So 2 o's, 3 n's, and we end up with quite a lot of words we could make. Let's have a look at an HSC question. Now in the HSC, they cannot assume anything because this is maths, not English. So in case you didn't know, the letters A, E, I, O and U are vowels. Okay. How many ways of the letters in the word algebraic are possible? So no conditions here, just how many ways, using all the letters, algebraic. Well, 9 factorial, and in fact there's only 2 letters the same in there, it's the 2 A's. So 9 factorial on 2 factorial. Okay. Second part of the question. So now, how many arrangements are possible if the vowels occupy the 2nd, the 3rd, the 5th and the 8th position? So we look after the conditions first. The condition is we're going to arrange the vowels. There are 4 vowels, but 2 of them are the same. So 4 factorial on 2 factorial. Right? So that's arrange the vowels, and then once we've got that order, we're just going to slot them into the 2nd, the 3rd, the 5th and the 8th position. That just leaves 5, here's another fancy word, consonants. So the number of ways of arranging the consonants. And so there's our answer, 1,440. Okay, that's all I really need to say. The only difference, of course, today is some of them are the same. So let's have a look at 10F.